So I'll cover up the theoretical portion first, okay? Like I'll just tell you. Then we can discuss like whatever the doubts or problem, whatever you have. So we have week 1 to week 4. Sorry, week 8. So today we'll discuss 5 to 8, right? Because 1 and 4 already, 1 to 4 already is been discussed. So week 5 and 6 are more, it's basically on the logical coverage, right? So the first, this thing is very easy. So to understand what a predicate is, uh, what are atomic propositions. So these are just some small definitions, like what are the connectives. So you can just go through those things. All are required, but it's okay. You have done in many where these kind of things. So truth table and all. Please go through all those things. So the from this slide, the things comes like this satisfiability and this tautology. Satisfiability, I'll find at least one case when it is a true. Tautology must be, it should be true for every cases, right? So what you can have some of the expression, this kind of boolean kind of or predicates are given, and you have to find out which are tautology or which are satisfiable. So this is the first kind of question you can be asked, right? So find out which are tautology. So you need to write a truth table for it, and you have to show that for all the cases it is going to give a true result. And satisfiability, you need to again have to draw a truth table, and you have to show that at least for one case it is giving a true. So here all are satisfiable, but none of them are tautology. So if you get a tautology, so this is a tautology. Sorry, this is a tautology because it is a or p and not of p. So if it is true, this will becomes a false. This becomes a false means it will become a true. So true, false, false, true always becomes a true. And if you find which is not tautology, not a satisfiable also, then it's basically the and between p and not of p, right? Because whenever it's a true, it becomes a false. False will become a true, right? So it will be always a false. So this is a slide which is important. You can get some questions. Rest are quite simple thing. It's all about learning and knowing the things. So okay, so this much only one this kind of question you can expect from this first kind. Okay, second I'll go for, I think this is the second one, right? Okay, second is the important, the most important, right? This predicate coverage thing, right? Mhm. So logical coverage in a normal way, it could be a predicate coverage. So a predicate will be covered for true as well as a false. So there should be a test case which will evaluate the entire predicate for a true, and entire predicate another will be evaluating it for a false. Whereas clause coverage will do it, it will make each of the clause a true and a false. And all combination of clause coverage means each clause should be true and false both, right? So that's all combination of clause coverage, and this is called a combinational coverage also. So uh, if you go for a predicate with in clause, since that combinatorial coverage, like you want to go for all cases of all combination of clauses, means you'll have 2 to the power n kind of number of test cases also, right? So uh, suppose you are having a condition where you are having two clauses, so clause 1 and with clause 2. So you want the first clause C1 has to be true ones and false ones, and C2 has to be also for true ones and false one. But combinations will be like C1 and C2. So you have to get all combinations. So it is a true, 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 false, false, true, and false, false. It is all combinations of uh, clause coverage, or it's a combinatorial coverage, right? So it should be 2 to the power n. Okay, so now this is a determinant thing, right, which will be more focused, and there will be a lot of question on this part, right? So once I say which clause determines, so inside a expression I may have a multiple clause, right? It is a C1 and C2 and maybe it's a OR of C3, right? So which clause determines your result, right? So determines result doesn't say it's a true means result is also true, but it says somewhere it is having an influence of your result, right? Maybe true is making it false, false is making it true, but it is influencing your result. So if I just go for a and, right, a or operation, so I want to find out when the clause 1 becomes a determinant, right? When the clause 1 will become determinant, the clause will become determinant when the left side is a false, this side is a false, because in that case, if this is 1, result is a 1. If this is a false, sorry, this is a true means result is a true. If this is a false means result is a false. For a and, the C1 becomes a determinant when the right hand side becomes a true, because if this side is false, result is false, this side is a true. But it is not must that it has to be false means the result has to be false. It can be false, result is true, but somehow it influence your result. That's the main portion is. Okay. So there is something called as a major clause and minor clause. So major clause, it is which is the major determinant of your result, right? So depends on the major clause, right? So which is also called as a active clause. So you are having certain uh, coverages. So first is the active coverage. So we basically try to find out our test case depends on the active clause, which is depends on the determinant, right? So we choose the minor clause in such a way so that the major clause will determines your result. So it's having a few types. First is a generic active clause. So I'm not going into details because otherwise this will take entire class to explain it. Please go to that recording if you are not there in the class in that day. So we have done in quite details all those things. So it is having a general active GACC, then you are having CACC and RACC, right? So RACC will be definitely a CACC, a CACC will be definitely a GACC, but reverse is not true. So some of the GACC test cases will pass and go into the CACC, and some of the CACC will go for RACC. So GACC says your GACC says that it should be a determinant. That's all. Then CACC required your result should be flipped. So if you change your active clause, your result will be flipped. And RACC result, your not only your result will be flipped, but your minor clause will becomes fixed. So these are quite clearly discussed in the recording. So please go through that. But you can expect a lot of question from this part. So some examples are also there. Please go through this. These are very important. Inactive clause coverage, it's quite difficult. Difficult in the sense you may not find all are feasible. So there are many cases this inactive coverage are infeasible, and the questions are mostly focused where this infeasible things comes up, right? So likewise, like a active clause, there is a GICC and there is also a RICC. There is not CICC. But important is RICC. Please look into the RICC very carefully, because this is the RICC is a situation in where in most of the cases you'll get something infeasible. Like you won't get sometime you won't get any test cases for when the result is going to be a true or result is going to be the false. But for true you will get some test cases, but for false you won't get any test case, right? So this infeasibility is very important for RICC. Please go through them. uh, so these are all these examples and all. So this is all about this, but these slides you can get a lot of questions. Okay, I was just taking Java revision before that. Those slides are still open. Okay. So instead of giving um, uh, the predicates directly, it could be given as a program form also. Like suppose I say for given this condition, so you have to say this is one clause. Maybe it's appended with another and something. So, but in this slide, the main focus will be on how to determine a clause, determine a predicate, right? So what should be your minor clause value so that your particular clause will becomes a determinant for a predicate, right? So these are the way. So suppose this is the predicate, so you need to find out when clause A will determine your B. So this should be the value. Your minor should be, the B should be false, right? Here not of B means it should be having a false value so that A becomes a predicate, right? So that's we have already learned. When B is false, A is becomes a determinant, right? So if it is bit complicated, I show okay how to do it with a truth table, right? So you can go for that recording also. Suppose sometimes this expression do not come in true or false directly, so it becomes a complicated expression over here. In that case, you need to draw a truth table to find out. So if you are doing that architecture, not system, computer system design, so there these booleans are explained in more details. But anyhow, we have also shown that how to do it for uh, this kind of situations, right? So these are again examples like how to do this. So this is with an example, code example, it is solved. But we won't give a this many code. We'll have, if we give a code, it will be 5-line codes, and you can check out this kind of clause or directly from the code. So it will be very simple. Something you are having one example also, right? One in the GA graded assignment, there is a small program. That kind of program you can practice. So we are not going to give so much thing. You may skip the entire thing. You can just see like how to frame the logic. This part only. So if you know this if condition, how to write a if condition, you can definitely form it. It's nothing a difficult thing. Okay, so
No, but then doing that, it becomes a little complicated, ma'am told in the lecture video.
which one?
I mean, from simplifying that into several nested if conditions, it becomes a little complicated.
No, no, I'm not telling a nested one. I'm telling a simple if, but with a and or this kind of thing. So suppose I give you, I say, so suppose program it is given like A is B plus C, right? And you are given a function like if uh, A is greater than D and C is equal to D, something like this. So if the question is The question is like uh, you need to find a test case for evaluation this logic, right? This predicate. It's a simple way to find it. Like if you just say this is a clause 1, so it's basically C1, C2, right? Quite simple. So there is a graded problem is there, right? I cannot remember which question it is, but afterwards I can give you. Just let me check it out. If it is there, I can access it. I don't know I'll be able to access it. No, right now I cannot access it. But I think you can access the portal, right? With you.
Yes, yes.
So if you have this week 5, I can show you afterwards. So let me
Sure,
cover it.
sure.
I'll show you which question it is. Okay. Or maybe I'll only show after some time. Let me finish it up first. Okay, so this is week 6, right? So week 6 start with FSM, finite state machine, right? From this finite state machine, these are very easy thing. You can just check out, but these terms are important. Uh, okay. No, here we don't have anything. FSM there is the FSM is there in the quiz one. That was a important thing, but this is there is nothing much to do. This is you can just go through once. You do not expect more many questions from this. Okay. This is also derived this kind of thing from a program, right? So given a program like whatever the conditions are given, suppose you are given, so I'm talking about this kind of conditions. Suppose this is given a condition, so how to find a test case for this? So you have to find this is a clause between a C1 or C2 or C3, right? Then you need to make this is as a major clause, right? You have to find out what should be the value of this so that it becomes a determinant, and you have to find out the test cases for CACC. Maybe if this is some value, then only it becomes a determinant, right? So like that way you need to do. So with that example, I'll show. So big program you don't have to prepare with. So we give a small program for exam. So these are also the same thing. How to convert that kind of condition into list. Okay, this is important. So how to write these forms, CNF form and DNF form, right? So if you have given a lot many kind of Boolean expressions like this, the predicates like this. So if you say find out which are in the disjunctive normal form, which is in the conjunctive normal form, you'll be able to tell it, right? So this is again this same kind of thing, like forming the equations out of it. So I'll show with that example because I'll keep something simple. This is also like only the theory you can go for. So satisfiability also, it's very difficult thing. We don't ask much of the things here. So I'll just revise what we have done from week 5. From the basic part, that tautology, satisfiability and valid, these three are important. The second slide, entirely everything is important. That when A will become a determinant, right? What should be the value, other value? So that is the main question from this slide. From this slide, you need to find all this GACC, CACC, then RACC, RICC. These are all important things.
Yeah, remembering the conditions sometimes becomes a little. I mean, one needs to be little careful for GSCC, CSCC, and all.
GACC, CACC, once you understand it clearly, like one example you do it clearly, it won't give much trouble. But one example you have to do which step by step derived all three. So that is something we have done that day, right? You're there, Vimlesh,
Yes,
right?
yes, 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 yes. That was we did in detail. So
So you can just
before
put,
exam, 4 5 questions we need to practice,
yeah,
and
yeah.
it will come through.
So previous year papers, you'll definitely get a lot of examples.
Okay.
So every paper having something, and normally I frame it in a way so that you'll get different cases.
Anything different than what we would have otherwise covered in sessions might come in quiz 2. Maybe like in quiz 1, there was a graph in which there were two terminal nodes, something like that. I'm saying.
No, no, that's two terminal node is a different thing. Like, so in a program, you can have a if part which is ending, and there is a else part which is ending, right? So we haven't done it. It's a different way, like a different case. We haven't put
Yes.
a case, but it can happen, right? Okay, anyhow. From here, nothing much important other than a program given a small program, and for a if condition or some other condition, you need to frame it in terms of these clauses, in terms of a predicate. Then you have to find different coverage criteria.
Yeah, that precondition and then converting those precondition into predicates.
Yes, yes. Okay. Week 7, there should be like 3 4 questions which comes every time and almost must kind of questions, and it comes from the first slide only. The second slide is not so much important. I'll show one format. You need to understand that format. That's enough. uh, First is given a code like this. Mm, Sorry, given a code like this. Maybe the question could be find out the PC condition for which it will reach the error, right?
So
It
we
reaches
need to
the
draw
error.
that tree diagram for this.
No, no, that diagram on tree bala we won't give it, because tree bala tree, like you can draw it in a different way. But which should be the PC value? PC value means like the Z0 should be equal to ZX0, and X0 should be greater than Y0 plus 10, right? It should be with a AND. So that kind of cases. So this should be the PC value to reach the error, right? So this lot of examples are there. If you go for the graded or anywhere, the old question paper, there are a lot of samples are there. The second thing is like it could come. What could be the cases? It will go for all the branches. Where is the example? The error wala example. So suppose given this code, so I'm on this code. Suppose the first could be like when I'll reach the error. Second, like if I want to test all the paths inside it, all the branches. So all the branches, if I want to go, this has to be false ones. Then this has to be true. This has to be false ones. This has to be true ones. This has to be true ones, right? Then only it will go for all the branches. Again, I repeat, this has to be false ones. Then this has to be true, and this has to be false ones. Then this
The
has to
outer if will be like true ones, false ones, and when outer if is true,
yeah. So outer
then
is, yeah,
entering then it will become true ones, false ones for the inner if. So
yeah,
total 3.
total 3. So when outer is one is false, it does not matter whatever the inner one is. The inner one could be choose anything. You have to give both the values, but once this outer one is false, it does not matter what the inner one is, right? So 3 cases will be enough. Okay, so that is one. Uh, these 2 questions you have to go for. And another is, rather than writing it like this, it could be also written as a dot formula. So I'll just show you. Symbolic execution, and there is a concolic execution. So execution tree, we won't give it as a question because that could be ambiguous. Like, you can draw it in many way. So you can just keep this portion.
So in symbolic execution, we are not giving any concrete value ever.
Yeah,
And
all will be taken
concolic,
as x0, y0 like this. Symbols.
concolic also we are not giving any concrete value, but
We no concolic we take both. We take symbolic as well as concrete.
yeah. So ma'am told that we start with some random initialization in
Ha,
concolic,
ha, ha.
but then where do we give symbols in concolic?
I'm coming to that. Concolic I'll go for. Okay, so two questions I had defined. One is how to reach this, then how to cover all the branches, and given a if condition. Suppose I say in the line number 6 there is a if condition which breaks, which create true branches. So what will be the condition for two branches? So this is what is that. At the line 7, two branches are created by the execution. So what are two branches? So if I ask for 6, only y and x and z value will be enough. But if I want the 7, you have to use x, y, z, all three values. So this is on the line number 7, right? So here you are creating two branches. This if. So what are condition for two branches, right? So this is one case. Then another case could be this loop. So it could be a for loop, while loop, or do while loop. The first question is like how we can symbolically represent the loop such that loop will execute at m times or n times and then terminate it, right? And there should be a loop condition also, but it is written like after m it stops. So so here like after n it is stopped, right? So it executed up to n, then at the position n plus 1 it is stopped. So what is the condition to execute? The n value should be greater than 1. So I need to understand for n times this n value is greater than 1, greater than 0. These values are greater than 0. But for n plus 1, I got a value which is less than 0. So that's why I came out of the loop. This is one question. And again, next question is once I come out of the loop, what should be the value of the sum and n? Right? Once I come out of the loop, what should be the status of my symbols? So that is this, the PC conditions. So once I come out of the loop, this is the loop up for n true executions, in true execution followed by a false execution, means n plus 1 is the false execution, right? Now what is the value you have accumulated since you have executed n time on to n? So this n value you are adding up, so it's a summation of n. So that value is going into your sum variable. So sum is this. And what will be the value of n? The n value will be n plus 1. So that is whenever out of your loop, because up to n it will execute inside the loop.
It can be changed in exam like from 0 to n minus 1, something like that.
It could be anything. Even a for loop can have a two conditions, right? So you'll get a lot of examples in the previous paper. If you are not getting any confusion, you just put it on the chat or put it on the discourse. I'll solve it and send you. But start it from now, because this time I have to respond only because Apnan is also busy with his test. So it may take for me little time to solve everything. Yeah. So this is a concolic. In concolic, we start with random concrete input and some symbolics also, right? So each time I'll have a error in the symbolic, right? A branching in the symbolic, I rectify my concrete inputs. So suppose I have a condition like this. So there will be two branches, one is true, one is for false. So suppose this condition only give it for a true, right? So I need to also take a concrete input for which it is a false, and accordingly I need to proceed next, right? So this concrete input you should know, because whenever you need to derive a test case will be in terms of concrete input, right? So suppose I say which test case will arrive you into the error, right? So you need to take some input, concrete input, where the z is equal to x and x is greater than y plus 10. or you have to generate a test cases which will give you the symbol coverage over here, means it covers all the branches, symbolic coverage. So symbolic coverage you need to find there are three paths you are getting, right? We have already discussed it will create three paths. So once this is false, once this is true, this is false, once this is true and this is true. So accordingly you need to define your concrete inputs. So that will become automatically your test cases for symbolic coverage. So you have to keep it in your mind. So if you go for the examples, you'll get a lot of examples over there. So don't worry, but go for all the examples. That's very important. And from this slide, I'll just tell you to do only one thing. Definitely you have to study the thing, but for exam purpose, just try to find out how in Dart we write it. See, Dart, no, you write it with these triangular brackets. So normally in symbolic testing, we use the braces, like the second bracket with and or, but instead of giving explicitly this thing, we use a triangular bracket with a comma, right? So writing style is bit different. That is only you need to remember here. So if I say dot coverage, everything you do as like a symbolic link coverage. There, anything, nothing different you have to do, but you need to write your conditions in this way. That's all. So we normally don't give anything from this part. So only the first slide which is very important here. So do it thoroughly from the Dart, only see how the Dart expressions are written. That's all. Okay. So this is again very intensive. So a lot of things are there. So normally we ignore this. There will be definitely some theory question from this part. So this is a caution. You have done all those things in software engineering maybe, but here definitions may be little different because these are made, everything made from the software testing perspective. So even you know all those things, please go through once again for testing. Okay. So the requirement, like which is product requirement, what is process requirements, the examples of all these kinds of requirements, right? So if you've gone for the software engineering, all of them are mentioned as a functional requirement over there. They haven't done this final, the fine coverage like a differentiation. So suppose there is a user requirement like this. Here it's given as an example. Sorry, business requirement is there. The mobile phone must have a charge 10% within the hours. It look like a performance kind of requirement, right? A non-functional requirement, but here it's typically a business requirement. So user requirements say here the language interface should come for the prominent languages. It's look like much more a functional requirement, but it's specifically a user requirement because it is about the user interface, right? So there is a little different kind of things over here. So please pay attention to this, because afterwards if you tell me that we read software engineering like this, my answer will be software engineering takes everything as a two things like a functional or non-functional, but do not do any fine differentiation between them. But here that is applicable. You need to understand what are the fine differentiations. Okay. So these are simple. Please go through once. Okay. So these two are very important. Rest of the things only see the definitions, right? So equivalent partition is the most important. We'll go for very details, but boundary values are also important thing over here. So these kind of examples, one will be there, right? So there will be a case given like this. So you need to find out will be how many cases, how many valid cases, how many invalid cases, this kind of things. So there are two invalid cases, there are three valid cases. So how many test cases you need? One, two, three, four, five. From each partition there should be one test case, right? So five test cases. So out of five, three valid test case and two invalid test case. Boundary value analysis is little confusing if you do not see it properly. So I'll suggest you just go through all the examples, right? For this only go for the definitions. You don't have to study much, but definitions are important because you have to answer the objective theoretical questions. But you can expect lot of question from this part. So you need to do all these things, huh? But little careful about this. So this is whatever you have, it's always matches, the formula always works. ECC also, every time you'll get it correct. This formula also works. But pairwise, this formula is not exactly how it is implemented over here. So normally pairwise we don't give for the exam, but try to have the concept, understand the concept and how we basically write it. Some ideas will be required. And if the question is on the pairwise is given, don't try to solve it using the formula. Go for the harder way, like write all the cases manually, then try to calculate it. So you practice with one example, you will be able to do this. But don't go by the formula. This formula have some like internal details has to be known. You cannot apply this formula in a straightforward way. Same thing is true for T-wise. T-wise also, like you can just go for the definition. Here I'm saying like PwC also see the example. You may have to solve some, like instead of two, maybe here there are three, here maybe two, something is there. So I may change the combinations, but you have to solve the example in the same way. But solve it manually, don't go for the formula. But T, just read the definition, that's all. But base case, I'll give enter thing. Like this formula always works. And one more thing in the base choice, in the base choice, like one choice will be given, right? Which is the base choice. You need to determine the other choices, right? Other test cases. Now you need to check out in your question, is it saying how many you have other than the base choice? In that case, the answer should be 4 here. But if it says totally how many choices are there, then it should be 5. Be careful, huh? Bit. So if it is total, means it is base choice plus all choice. So this formula is for total. So that's why it is plus 1. That includes the base also. But if you just take this formula, that's other than base choice of how many you are having. So base choice is given to you, but from there how many you can derive, that extra. These are, you can just see it, that's all. Okay, so I have actually done this, but 1 minute, I'll just try to fetch that problem. Uh, one that kind of problem I'll definitely give. 1 minute, huh? I have to search in my, I've stored it somewhere. Yeah, I got it. You can see, right?
Yes, visible.
Suppose you have asked for predicate for this. So Z is what? Z is this clause, right? So you have to assume it's basically Z is this. So that means actually this is a clause which is looking like, oh, I cannot write here, right? This is a PDF, right? Why I can't write into it? So anyhow, like I need to replace Z with X less than Y. So I'll suggest rather you solve this question. It is there on your JQ. This is a
Sure, sure.
see,
We'll do that.
so if you are getting a trouble, please post it. I'll give you answer. But one this kind of thing will be there. So here it is asked for RICC, but there could be this question is RICC or anything else, or maybe in this form also, right? This all the forms are important, and much more this. So here you are getting all the cases, but there could be also a problem like uh, where some cases it is not infeasible, not feasible, right? So you solve this. If you solve this like all like this is a comprehension type of question based on this 1 2 3 4, yeah, up to 4 all these questions are there. So if you all solve all this 4, you'll be able to solve everything based on this kind of code. Okay, so this is it. So anything more?
So that formula for A or A and B, something like that. So
Uh-huh.
how many different kind of formulas could be asked in the exam? Or we need to know.
Formula could be anything, like somebody can make anything from their mind, but we just see
No, no.
that.
What I was basically asking that simple formulas like A or within bracket A and B, Just things like that, which has been explained in the lecture videos. Well, we can
It
remember.
will be like 3 or 4 variable, not more than that. And it will be like, it will be with and or, right?
Yes, and or but yeah, but it if there if the formula is a little too exhaustive,
No, no,
then
we won't give very exhaustive one.
okay, okay.
That is sure. But you should, if you go in a proper way, you'll get the answer. We
That
won't give it very difficult one. We know that lot of pressure comes in the exam, so it's okay. You will be able to do it if you know the procedure. That's all.
yeah, doing that keeping A equal to true and A equal to false in
No,
the
it won't
XOR.
be A and B also. A and B or A or B. It will be more complicated, like A and B or C, or A and
Yeah,
B or
that's
C.
true, but we need to focus on keeping true or false only for one variable
Ha,
at a
ha, ha,
time.
ha. Now we give it for one variable only, not for all the combinations.
Okay, okay.
Yeah, exam purpose will give for one variable. Or otherwise we'll give you directly the truth table with the determinant. So that you'll directly find out from the table like which are the clauses. Okay, so if you don't have anything,
Uh,
uh yeah, no, no. Yeah,
I have a few doubts in the previous year question papers. Could
yeah.
you please access the link that I shared in the chat? Uh,
Yes.
in page 29, sir, question 34.
Can you share the question as well, sir?
Which question? Oh, it's not shared. Okay, okay. I thought I'm sharing it. Okay. So I'm on page 29,
Question 34, a little above.
34, right?
So So for ECC, we will just count the number of blocks, is it? Like the blocks given in the table above.
What is the minimum of test required for each Acha, ECC. Where is the question? Here, right?
Yes, sir.
Here is the question, right? So we are having 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, right? So,
The formula is maximum.
yeah, maximums, it's 4 straightforward. I'm getting it, but I'll just help you to find out how we are getting it. Where is ECC? Yeah. One value from each block has to be taken for each combination, right? So I take one value from the first set, say one value from the second set, one value from the third set, like that. So if you go in that way, right?
Yes,
Hello.
sir. Yes, sir.
So if you that go in that way, so maximum you have to go for 4 only, right? Because it depends on what it is the maximum size case you have, right? That is having 4 block. The size partition that's having the 4 blocks. So if you
Yes,
go
sir.
inside,
Got it.
the formula says that's a maximum of the blocks, right? So maximum we have size 4. Yeah.
The next question, sir. 35.
Sir, sorry to interrupt. I had to ask one thing from the same place.
Yeah.
Suppose there are 4 blocks, can it ever be the case that there are no value in block 4? There are only values till block 3, but block 4 is written anyhow. Can that happen ever?
If you do not have a partition here, then you don't have to consider, right? That means that block is not in use.
Okay, so even if there is written, suppose in this question there is a block 5, but it is completely empty.
Then
So we
you
don't
yeah,
think
don't
of
have to
anything
consider,
further.
yeah. Because these partitions are important, right?
Okay,
Each block mention a partition, right? Yeah.
right.
Yeah, but what could be the purpose of writing block 5 and everything empty under it?
I don't know. There, yeah, it should not be actually. She's telling like if the table is
Or what
created.
if there is a trick question or something?
Yeah, yeah. Yes. So
Next is question 35, sir. The PWC.
okay, I need to solve it now.
Maybe you could give a hint. I will try.
Hint won't work. You need to solve it manually. Because I told this PWC is something.
Yeah, that formula that doesn't work
The formula
always.
doesn't work. So first you need to make the pairs like this. Okay, I'll try to do quickly if I can. The first version have how many? Oh, I cannot write it. So let me go here. So you can remember, no, which partition have how many pieces, blocks. So we have, say we are having A, B, C, D on the first one. Then second one, how many? Criteria, how many? 3, 3, no?
3, sir. Yeah, 3.
Oh, 3, 3, right? It was
Yeah, both are 3, 3.
1, 2, 3. And this is a X, Y, Z, right? So first let us make it 2, 2 pair, right? So I can have A1, A2, A3, A4, right? Oof. 1 minute. So I have to make all the pairs A, X, A, Y, A, Z. Then I have to make B1, B2, B3, B4, B4 why I took BX, BY, BZ. Then I have to take C1, C2, C3, C4, CX, CY, CZ. I need to take D1, D2, D3, DX, DY, DZ. I have to take 1, 2, 1, 1X, 1Y, 1Z, then 2X, 2Y, 2Z, 3X, 3Y, 3Z. So this is 2 pair. Now I have to make a combination of 3, right? So I can take first A1X, then I can take A2X. What I'm doing, I'm combining this with all those 3, right? A3, no, sorry. If I combine all those 3, like I'll have A1X, A1Y, A1Z, right? Now see, 1X, 1Y, 1Z, this is tested for all, right? So now I have to take a B. This combination could be anything because I have combined it together for every case. Then I'll make it C. I'll combine anything of this. So this will be 5, right? Then I'll have A 2X, A 2Y, A 3, A2Z. And I can have for B anything here. I can have C anything here. Because all combinations are 2 with anything is tested. Then I'll have similarly, sorry, I'll have this 1 is fixed, right? Here is 1 is fixed, but this I can have anything. So here 2 is fixed. This coordinate can be anything. The third one can be anything. Then I can have, because this is see, 2 is combined with X, 2 is combined with Y, 2 is combined with Z, right? Then I'll have C 3X. Let me complete, I'll explain it. 3Y, 3Z. Then I can make A fixed, 3 fixed. This could be anything. A fixed, 3 fixed. This could be anything. So I'll have 5 into 3. That should be 15. Right. This is what I can have. So first what I have done, I have made this to fixed. I've
Could
varied.
you please explain in a little detail? I didn't understand the entire process.
Then I have made this fixed. I have varied this. Then I have made this fixed. Sorry, up to this fixed, I have varied this.
So
Right.
D is not used to
Uh-huh.
D comma 1, D comma 2, that is not combined.
It will be A, sorry. This will be B, this will be C. I'll just showing with this example because that is very big. It will take so much time for explaining this. So see what I have done. If you see this, I have made this A and X fixed. Right. Then I'm keeping A. Okay, sorry, I have to vary this Y, right? This is I've done wrong. Then I'm making this BY fixed. I'm varying this. So this is my variable. This, okay, I'm doing something wrong here. Give me a minute, huh? Let me find out where I'm doing wrong. Let me write it once again, huh? So I want to take the 1 to A1, then say the third one I'm varying, I make it as a X. Okay, then A1, I make it as a Y. I make A1, make it as a Z. Then I need to have extra clauses, that is B. This could be anything. Sorry, this could be anything because this is I'm varying. I have covered X, Y, Z all. So this is X, Y, Z all covered. So I do not matter it what I take. But I haven't covered the combination of B and 2. So I need to take. And I haven't covered the combination of, sorry, A and 2. And I haven't covered the condition A and 3. So that covers all the combination with A. So I have A1, A2 and A3. And I have covered the condition AX, AY, AZ. Right. So all the combination with A is covered. So the point is you need to cover whatever you have written as two pairs. Right. So if you look at here, this A1 is covered, A2 is covered, A3 is covered, AX cover, AY is covered, AZ is covered, right? So all with A is covered. Next with B, how you can write all the combinations. So for B, let me take it as a 1. I take it as a X. So Y. So it's a BX, BY, BZ. So up to now, how many pairs I have covered? B1, one pair I have covered. BX I have covered. BY I have covered. BZ I have covered. So the third one all I have covered. So for rest of the cases, whatever the third one is does not matter. So third one I can take anything. But B have to combine with 2 and B has to combine with 3. So that covers all the pairs of B. See, what could be the combination of B? B could be combined with 1, B could be combined with 2, B could be combined with 3. And B could be combined with X, B could be combined with Y, B could be combined with Z. So you cover all the pairs of B. Now you have to cover all the pairs for C, right? So for C, what will be the things? You can have C1, X, C1, Y, C1, Z, right?
Will there be 36
I'll
pairs, such pairs in total?
just do that. Then C2 is not covered. The third is covered for all. Then C3, this is covered. Okay, so I get another 5. So this covered everything for C, and for D, what I'm going to get? For D, I'll get 1x, D, 1y, D, 1z, right? Then D2, whatever it is, D3, whatever it is. I think all D is covered, right? D1, D2, D3, DX, DY, ZS. So in how many A7? So I've covered everything. 1, 2, 3, 4, 5, 6, 7. So it's of 20. So you should get 20. No, it's wrong.
20 is not in the option itself.
So it's wrong. It's wrong. Something is wrong in this question. It should be 20 only.
Okay, sir.
There is something wrong about it. It should be 20 only. So you got, no, the concept is simple way. You need to cover all this fair in the test cases. So how do you write it? The simple way I can write it, say A1 I can write directly. So this first pair is covered, right? So you're covering this. So I'm striking out. So A1 is done. So let us do this as a X, right? So do this as a X. Then this 1X is also covered. Then you can make this fixed. Then make it is Y. So this is also covered. A1Z. So Z is not there here in this question, right? So it's just X and Y are there. Okay. Then XY, both the variation I have, but for A, this 1, 2, it could be 3 also. So I make this anything. So 1, 2 is covered. And A, 3, this means this is also covered. So this covered all these things. Now, if you look at AX, see AX also there. So this is also covered. And AY, that is also covered. So A, all the options are covered, right? All the pairs. Now, you have to go for B.
B will be also 4.
No, I'm doing something again wrong. So shall I do it next day? So I'm going wrong something.
Saturday morning, we are scheduling one.
I'll do this. Somehow I'm going wrong here. Okay, maybe we'll go for the next question. Yeah.
Okay, sir.
Yeah. Saturday I'll discuss morning.
I mean, tentatively, what time, sir?
10, around 10.
Okay, thank you.
Yeah.
Sir, Saturday 10 a.m. there is another Industry 4.0. Can we have it at some other time?
12.
Yeah.
Okay, let us have around 12. Okay, next which question?
Can you explain 36? 36 is what?
So let us take the this series on Saturday then.
No, this is easy, right? So this is already like done many a time, right? So the first pair having 4 cases. Now this is something I'm missing because pairwise gives a lot of trouble always. So first one I can take A, B, C, D. The second one is 1, 2, 3. Third one I'm having X, Y, Z. Right. So base is given like this, right? So I'm suppose I assume this base case is I'm taking A, 1 and X. This is my base case, right? So I'll make this A fixed and 1 fixed, and I'll vary the last one. So it could be a combination of Y. One is Y and A1. There will be a Z. So I can have with this two, then keeping A and X fixed. Varying this, I can have one with 2 and another is 3. and keeping this to fix a and x, 1 and x, right? I make 1 and x fixed. So then I can vary it with a B, C, and D. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 3, 4, 5, 6, 7, 8. Yeah, it's 8, right?
So can you please say once again what happened with all of the combination?
Yeah, I'll
A
just
bit confused.
no, it's not confusing. It's very simple actually. The this is pairwise is a confusing. That's why I told already that it's difficult. So here I had, suppose ABC 1 2 and XY, right? So they took it as a base case as this A1X, right? A1X.
So ABC are different levels for the attribute one, say
It's written already.
1 2 for second attribute and
Ah,
XY Z for third
so these
attribute.
are your blocks. It's AB. Okay, sorry. This is for uh, sorry, which one I took? Okay, it's AB. It was ABC or what? I took it wrong actually. What was the cases? AB 1 2 3 XY, right? I took ABC actually. That's why I'll make it
AB 1
A
2 3 XY.
1 2 3 XY. So the base case is A1X. A1X. So what you need to do, I'll mix one variable and rest of the things are constant. Like first say I'll make A1 constant. I'll vary this part, right? So X is the base choice. I need to go for other choice. So other choice could be Y, right? So this is one case. Then rather than first one making fixed, I'll make the first and third one is fixed. AX fixed. So what could be your choices? One is already taken, so you can take a 2
2 and 3.
or you can take a 3. Okay. So then let the first one is variable, second two are fixed. Right? Then what is your
A and
choice? A
B.
is already taken, you can take B. So these four are new cases. Along with base cases, there are 5. So there are
Okay.
4. Along with the base case, there are 5.
So then answer will be 5, right?
If you say total, then it is 5. It say others means there are 4.
Okay, understood.
If it is saying total how many cases, then it will be 5.
Okay.
Suppose it's like ABCD, I mean, more number of partitionings per attribute.
Huh?
Then we need to generate as many cases every time.
No, I took this. No, this is a simple formula actually. So that's why I'm stealing. Like it is B minus I plus 1. So it's simple way. It's 3, 2 plus 2. So totally 7. And if you include the base case, it is 8. That's all. Got it, no?
Okay.
It's a
Yeah, but
summation
then
of 3
Yes.
minus 1 plus 1. So it's a 3 plus 2 plus 2, 7 cases. Including the base cases, there will be 8. That's
so
it.
summation of B minus 1, then what is the BI total?
BI on each block. These are called BI.
Okay. So every block we are removing one and then summing it up. Okay.
Yeah.
Yeah, but then this is just to find out the number. What if any illustration is being asked? Like
Illustration is this, right? How I'm getting. Oh, for this, it will be like if it is 5, 6, we'll ask that kind of question like generating test case. Otherwise, I'll ask the number only. But for these also you can generate. It's not difficult for ACC. It's easy only, right? If it is given that your base choice is A1X, I'll make this fixed, these two fixed, and X is given, then there will be two choices, Y and Z. So this is plus 2. Then I make A and X fix. So 1 is given, there could be two more choices. So plus 2. Then I make 1 and X fix. A is given, so there will be three more choices. So plus 3. So it's a 7. 7 plus, this base case is already given, that's plus 1. That's all, right?
Yes.
So what I told, no, this base case, ECC, and that first one, they are basically always calculatable, and that's easy. This pairwise also you can calculate, but somehow something I'm missing right now. Yeah, next one.
Next one is about prime path, sir. I have solved it. Can I share my screen?
Yeah, 1 minute. Hmm.
Is it visible, sir?
Yeah, it is coming slowly. Yeah.
I tried solving it. The answer is 6, but I'm getting only 5 paths.
I'm checking. I need to check it. I cannot tell
This
you.
is quiz 2.
Yes, yes.
So it is 1, 2, 3, 4. Okay. Then 1, 2, 1, 4. Okay. From 2 it is 2, 3, 2, 4. Right. Then from 3 it is 3, 2. Okay. Okay. From 2. Okay. From 1, 2 you can go 1, 2, 3. Correct. You can go 1, 2, 4. That's the final. Then 2, 3. You can go 2, 3, 2. Correct. Then you can go 2, 3, 4. How you are getting? Huh? 2, 3, 4.
2, 3, 4.
2, 3, 4 on the second two length 2. 2, 3, 4.
Oh,
And,
that is mistake.
That's wrong, no? 2, 3, 4 won't be there. Okay, 2, 3, 4, 4 won't be there. Then with 2 we'll have only one loop only. Okay. Then from 3, 3 to 4 is fine. So this one path won't be there. 2, 3, 4 won't be there. Okay, next with 1, 2, 3, we'll have 1, 2, 3, 4.
no,
1,
3
2,
to
3,
3 will be there also, no?
this is also wrong, right?
3 to 3.
1, 2, 3, 4, how I'll have?
1, 2, 3. Okay, that is the mistake.
That is also not.
3 to 3 also will be there.
Uh,
Star with a star.
Can you
Okay.
do it right now? Can you write here, or I
Yeah.
can solve it quickly if you want. Do you want me to solve it quickly?
Yeah, sure, sir.
This we can do
Yeah.
this.
Uh-huh. Yeah, Vimlesh?
Yeah, we can solve this. I mean, we have solved this in live sessions.
Yeah, now that I've known how to, like, what mistake I've
No,
done,
if you do not know, like I can solve it once for her. No problem.
I will try solving it, and if I still
Okay,
get
okay.
on discourse.
Okay. Okay. So errors are quite clear. Like 2, 3, 4 cannot be there. 2, 3, 1, 2, 3, 4 cannot be there. Yeah. So these two are wrong.
So this prime path and all is also coming in quiz too.
Yeah, everything is there. 1 to 8, right?
That's I know. Okay, good. I mean, good that it is coming. That's what I'm saying.
Okay.
Can I ask another last
Yeah,
doubt?
sure.
This was the question, sir. 97.
97. Which one 97 is?
Can you see my screen?
Yeah, I can see. Just can you drag it? I cannot see the number. Why I cannot see the
This
number?
one, this one. 97.
Okay. Last page. Okay. When it comes to partition bit testing with multiple input. Which of the following technique is better? It's a decision table. It's basically written on the slide only explicitly why it is better, because decision table goes in a cause and effect way. So if you just open the slide, it's directly taken from the slide. So that's why I told for boundary value and partition, you just go it in very details. For other, read the definition. So this is basically the comes into the definition of the decision table. So
Yeah.
Sir, in one of the questions I saw earlier, the question was that this was the exact same question they were asking, and the answer was also same. However, in place of partition-based testing, it said functional testing. So, do they both mean the same thing, or?
no, functional testing is a different. You can Anana, you can just do what? No, you can just read the definitions from the slide, right?
Okay.
If
Yes.
you are still not getting it, then I'll explain it, because I need to open the slide and you have to show it. Like if you just, these are directly taken from the definitions what is given on the slide. So if you
Okay.
just read them, you'll understand. That's all.
Yeah. Okay. Thank you, sir.
Thanks. So we'll have a quick round on Saturday at 12 o'clock. Okay, that's all today. Let me.
Thank you, sir.
Yeah, thanks.
Thank you. Thank you.
Bimlesh.
So,